All right, hello and welcome. This is a video response to Thomas Kandera, who stopped by the channel and had some comments about, uh, or had some questions and comments rather, about how the flat Earth model works versus the heliocentric model. And from his understanding, he made the claim that the heliocentric model explains reality very well, and on a flat Earth, nothing works. And by nothing works, I'm assuming I forgot to mention this in the reply, but I'm assuming that he means things like technology, satellite communication, GPS, airplanes, cosmological predictions, those sorts of things. So I thought it would be cool to do a video presentation and show why those things aren't proof or aren't necessarily the proofs that he thinks they are. Because when people often say that nothing works on a flat Earth, like they're talking about GPS and satellites and stuff, and they're just kind of giving the benefit of the doubt to that technology and how it's claimed that it works, and they're not really familiar with another possibility that's much simpler. So let's see. So part of what I'm interested in doing as well was showing people that people can have conversations about things and have different opinions and not hate each other, not freak out on each other, and it doesn't have to be like a you're right versus wrong, because something ultimately that I recently kind of came to the conclusion to uh, is that the you know is that the heliocentric model is super philosophical, and at its core the people that promoted it the most admit this, and we'll go over that because a lot of people might not have heard these quotes before, and when you hear them and you really process who's saying them and at the time that they say them, and you're like, oh wow, that's interesting. It kind of it might shed some light on why flat earthers disagree with a lot of the quote unquote science or mathematics rather that are proposed to explain our reality and support the heliocentric model. All right. So this comment was from Thomas as well on the Terry Eichart video that I have re-uploaded on my channel that explains the day and night seasons, the day and night and seasons. So he had some questions about because perspective and whatnot, and yeah, we're gonna go over that. So the compression of atmospheric conditions and clouds, etc., block the sun as it moves away, and he's not particularly sure what I mean by that. So I'll show him where we're gonna go through these and hopefully get a better understanding of. Hopefully by the end of the video, he'll have a better understanding of my perspective. And then he actually had a comment or another follow up question as well, which which we'll get into. But yeah, it'll be interesting uh, to see his follow up and stuff to see where he's coming from. So let's see here. His additional question was, he says, usually I ask this question uh, after someone responds to me or whatever, but since you're taking the time to make a video, I'll ask it now so you can have a way to insert it into the video. So he says, I live in Strasbourg, France. Could you using the model, the flat Earth model, he's saying, use the flat Earth model presented to me using its parameters, distance to the sun, speed of the sun, flat Earth perspective, vanishing point, and all that, whatever you feel you need, and then can you compute that for him and tell him the duration of the night at Strasbourg, Burr, for tonight. And he wants me to be precise so he can follow along and do the computations himself and explain the process and all that stuff. And then he says that he will in turn do the same using the heliocentric model, and we can compare and see what's going on there. So he reiterates, he kind of simplifies what he says and says, so basically I'm asking for a working predictive model for him to evaluate. And then he says, if you can't provide that, then maybe what you're about to deliver is not an explanation, but just a narrative. Really waiting for you to work on that. And my initial response to that is, I don't have a predictive model for that or a way to compute that for you. But I am interested in how you do it on the heliocentric model. So, definitely show me that. But I also wanted to point out that math is a language, right? And its equations are descriptions of reality. So math is also a narrative. It's not, it's descriptions of reality through equations, and you can just make equations, it doesn't, it's not necessarily indicative uh, of reality. And yeah, so with that being said, I wanted to kind of go over some of the big equations or descriptions or narratives of why people are of the heliocentric worldview. And I think we can get it. I think we'll jump into that with let's see. So let's just start off with just proof that the earth moves, right? Let's start there, because a lot of the science and experiments back then that people were doing, like the Michelson-Morely, Michelson-Gale, and all that, we're starting off with the assumption that the Earth was a sphere and moving through space and all that. They already were flat earthers. They were already heliocentric enthusiasts, And these experiments were trying to prove that. So let's get into that. So this is from Cornell, and the question is there proof the Earth moves? How do we know the Earth and the other planets go around the sun, not the opposite? And this is a very good question. For some time, it was accepted that the planets, including Earth, circle the sun. There was no direct proof that the sun, or that the Earth moves and not the sun. Okay? So, no direct proof, but they went ahead and did that anyway. Now, they did that on philosophical grounds, and we'll get into that in a bit. So, when we get to the first proof of the Earth's movement, we have a guy named James Bradley who discovered stellar aberration. And I didn't know what that was, so I went and watched this video on stellar aberration from a Stanford University lecture. And this guy gives a nice rundown of it. I'll give you the TLDR. So there, basically, the James Bradley guy found that in order to get a better view of the stars, you had to correct at an angle, and this is the angle right here, correction of how much higher you have to tilt your telescope, because the light, when it's because the Earth's moving, when the light comes down, it'll hit at a different spot. And if you want it to get right in that center of the telescope, in the good spot, you have to correct at this angle. And this is the velocity that the Earth moves over the speed of light, and this is how you get the angle right here. And the angle is 0.112 or 0.12 degrees. And so not very big. And you got to remember, this was in this was in 1725. So there had already been observations, predictions, recordings lots of data on the movement of the celestial bodies. I don't think anyone ever really had a problem with modeling out, like Tycho Brahe and what was the other one? Kepler. Yeah. I don't think those guys had any problem figuring out, the movements and stuff, and for their models, or Ptolemy and all that, uh, without adjusting for that degree. So I don't know that stellar aberration is a proof that the Earth is moving in any meaningful sense. And so we'll go down here to parallax. They cite parallax as another one, and that was actually um, what we were talking about on this video here, where I clipped Jaren as I'm talking about stellar parallax, and you were saying that that it's incorrect or whatever, or that he doesn't know, that you were saying that it was just he doesn't believe in the what did you say exactly? Okay, argument by ignorance is not an argument. Jeranism don't know how to measure small angle and then assumes that others don't either. Seems to be right. Well, that's not even correct at all, because uh he perfectly walked through how it's done, and that it was I asked, this is a actual professor at some university in California, I believe. I don't know which one, but you can probably ask him, he'll tell you. But I asked him about it, and he was like, yeah, it's more or less correct. He nailed it. So this is an accurate representation, I would say, of what's going on um with that. So anyway, so anyway, well, I made the claim that where was distant sky, vantage point. Hold on one second. What did I say? Oh yeah, so in terms of the parallax things, like, no one really, no one measures that. It's imperceptible. The way that they do it is they have a, quote unquote space telescope satellite thing out there, and they get that called the Gaia 2, and it's the parallax measurements are taken from the Gaia 2 data set, and then they have, like, astronomer students and whatnot go through the data, and they check it and stuff. Let me see if I can find Harvard. No, it was I think this is it. Yeah. Yeah. So they go over the data, and they have math equations and stuff to determine the accuracy of the data, and if it's too small, don't count it. If it's if it goes in the other direction, negative parallax and stuff. So they're reviewing. It's a guide on, like, how to review the data from the data set. And this is where it gets into the measurements are so fine and precise, because what they're doing basically is they're saying that they're capturing, a small angle uh, of the sky, and then they're breaking that down to like 1/32,000th of a degree, or of a fraction of a degree in that small section, and they're just kind of analyzing pixels. So it's like a man-made algorithm to analyze pixels, that they say, like, 1 pixel would be, so many parsecs, because that's how it all comes out to. So it's a digital process rather than something that people actually observe, you know. And to their credit, this process would technically work, I guess. It's basically just a scaled up version of how parallax works on Earth, but the distance is that you can verify the distance, and you have to have a baseline through that. So these distances that they have, though, end up being 75 sextillion miles away. And then if something's 76 sextillion miles away, I mean, that's completely irrelevant. There's no reason to even like concern yourself with that. That's you know, and it just happens that it has to work out that way because of how they've done the scaling for the arc seconds and milli-arc seconds into parsecs to get the distances. And you know, so uh, so I think that stuff was correct. And you mentioned we can't that we should get into that on another topic or whatever. But yeah, I'd definitely like to see you touch on that, or have some other, or like see what your insights are on the parallax situation. Um, and then so we'll come down here to the closing art. Okay, yeah, so we'll get into the Doppler effect, right? They say that there's this the cosmic microwave background and those sorts of things. And well, where's that at? So quotes. Where is that? Oh man, one second. How can I do this without taking too long? Uh, nope. Who's this guy? Oh, okay. Yeah. Perfect. Okay. So, quote from this guy. It was uh, YP Var Sheeny. I don't know why I just didn't scroll up. I panicked so hard. So I'm trying to do it all in one take. I don't like editing and all that stuff. So um, just bear with me here. Sorry about that. 1 second. Okay. So we got this guy is a PhD Department of Physics at the University of Ottawa, Canada. Published a he published a paper called "The Redshift Hypothesis for Quasars: Is the Earth the Center of the Universe?" Why would you say something like that? That's crazy. What about the Copernican Principle or whatever, where anything that says that must be clearly wrong. uh, let's see. So the abstract. It is shown that the cosmological interpretation of the redshift spectra of quasars leads to yet another paradoxical result, namely that the Earth is centered around the center of the universe. Consequences of this are examined. Oh, and before we continue, shout out to Witsit Gets It, who did a presentation on Globebusters a few weeks ago, and he pulled out a bunch of these quotes and stuff that that he and Jaren and other people from the internet and stuff have found from PhD level high level people in physics and all that stuff and astronomy that are either geocentrist or admit that uh the heliocentric model and the geocentric model are pretty much the exact same, if not interchangeable. And actually, we'll get into how interchangeable they are with the preferred frames of reference and all that from the relativity stuff. um, so so yeah, let's we'll keep reading here. But anyway, shout out to Witsit, shout out to Globebusters and all those guys. And anyway, he brought up this quote right here. And so this is from the actual paper, and we'll kind of read through it. There's a lot of math and data sets here. We'll kind of skip over that and then get to the end there, but we'll just read a little bit here. So this guy, he quotes Einstein distinguishes between two main criteria for a good theory: A, the external confirmation of a theory which informs us the experimental checks of the correctness of the theory, and B, the inner perfection of the theory which judges its logical simplicity or naturalness. G. Holton, 1970 thrice. 1 second. All right. A few years ago, it was pointed out by G. Burbage, G. Burbage in 1968, that a number of quasars have an absorption line redshift of 1.95. He also drew attention to the fact that there are four quasars, namely, and then I'm not going to bother reading these, but these are the names. It's just ridiculous names that they have for these, whose emissions redshift lines red whose emission line redshifts are extremely close to 1.955. Ooh, so we went from 1.95 to 1.955, dude. Things are heating up or whatever. The absorption line redshift at 1.95 has been subsequently discussed by Burbage's and others in a number of papers. It appears, however, that the significance of this coincidence of the four emission line redshifts at 1.955 has remained unprecedented or unappreciated. Also, it is perhaps not recognized that there are many other perhaps not recognized that there are many other similar groups where the redshifts of two or more quasars lie very close together. In this paper, we discuss a very serious consequence of these coincidences, assuming the redshift hypothesis for the quasar spectra. In 1968, there were 20 QSOs with emission line redshifts greater than 1.9. Burbage calculated the probability chance of this coincidence for the redshift lines in this equation, and whatever that means, where P, the probability chance of the red, and we're just gonna kind of breeze through this because this is just where they're like, I don't know, man, what are the chances that it's whatever. Anyway, so in conclusion to all the mathematics above mentioned, from this discussion, it is obvious that if two or more quasars have the same value of z, that they are at the same distance, though in different directions from the Earth. In other words, assuming the cosmological redshift hypothesis, the quasars in the 57 groups in Table 1 are arranged on 57 spherical shells with Earth as the center. This is certainly an extraordinary result. Some of the possibilities that we shall consider to accommodate this result may be disturbing, but we must consider these possibilities dispassionately. Number 1, coincidence in distance could be possible if there were clustering. However, an examination of the coordinates of the various members of the individual group show in most cases there are no such correlation, hence this explanation has to be ruled out. 2, quasars are arranged like atoms in a crystalline lattice, with the Earth being either at an empty lattice site or a substantial interstitial site. Should that be the case, one would expect some pattern or irregularity regularity in the direction of the quasar belonging to the central group. No such evidence of this is found, and thus that must be abandoned. So whatever is going on here with their crystalline lattice theory, they were like, that's a no-go. And then, so for number 3, the Earth is indeed the center of the universe. The arrangements of the quasars on certain spherical shells is only with respect to the Earth. These shells would disappear if viewed from another galaxy or quasar. This means that the cosmological principle would have to go. It also implies that the coordinate system fixed to Earth will be the preferred frame of reference in the universe. Consequently, both the special and general theories of relativity must be abandoned for cosmological purposes. We must also consider the two possibilities which have been discussed in the literature to explain the apparent redshift of quasars. The difficulties in assuming that the redshift are gravitational are well known, and we need not repeat them here. In addition, there is no reason why there should be coincidences in the MR values. Z is essentially a function of MR for the gravitational redshift. For the local Doppler interpretations of the redshift has serious difficulties. In addition, we'll have to explain why the quasars were ejected in shells. All right. We are essentially left with only one possibility. Number 3, the cosmological redshift interpretation. However, before we can accept such an unaesthetic possibility, we must raise the question, are redshifts even real? We wish to point out that we have proposed an alternative explanation to the spectral quasars, which is based on sound physical principles, does not require any redshift, and has no basic difficulty. All right, I'm not familiar with what he has proposed, but yeah, so there you have it. They've give me 1 second. Yeah, so according to the the CMB and all that shit, the cosmic microwave background, um, that people cite as proof, well, it actually just fucking backfired because uh, these quasar clusters or whatever wouldn't be viewable from anywhere else. Therefore, we are in a unique position, and they're also equally far apart from each other, meaning that they are equal distant from the Earth. So there's that. And where are we going from here? Yeah. So anyway, back to the Cornell thing about proof the Earth moves. All these phenomena demonstrate the Earth's motion relative to other objects. It is important to note that according to the theory of relativity, we can always move the reference frame in which the Earth is not moving, i.e., its inertial reference frame. So it is technically possible to define the reference frame in which the Earth does not move while the sun and planets and stars orbit around us by making this reference frame consistent with our observations with Doppler shift and parallax would be very complicated. So it's much simpler to explain our observations in a reference frame where the Earth does not move. Occam's razor directs us as scientists to use the simplest explanation whenever possible. So there you have it. Uh, uh, that's really interesting, right? And they're saying, well, Occam's razor, bro. Like, the simplest way is the right way, right? So we were just talking about Doppler shift in Guy's paper, and that's not looking good for the heliocentric model. And Occam's razor tells us that we should go with the simplest explanation, and also we touched on parallaxes, and how those are measured through the Gaia 2 data set and all that, and how it's a computer analysis of what would potentially be computer generated data. You would never know if it's an actual observation of the sky or a observation in a computer simulation to yield those results that would be in favor uh, of the heliocentric model. So you could say things like, well, Occam's razor, parallax, Occam's razor. Well, what? Let's see. Star trails at the equator. All right. Oh, I forgot the U. All right. So star trails at the equator. Let's see. Where's a good one at? Yeah. All right. So we got star trails bending off in this direction and star trails bending off in this direction. Right? And we got some going straight. Now, they're all supposed to be going the same direction. So this can't happen if the stars rotating is due to the earth rotating. Us rotating under the stars, basically, is what they're saying, how it happens. So we wouldn't see it like this unless it, I believe, I mean, I haven't modeled it out, but the only way that I could imagine it happening would be if the sky was a dome or something, like a sphere, a dome rotating over us. And what we were seeing was just the light bending around the dome as it rotates. It's like it's an optical effect of the fact that it's the sky rotating and not us. And that's what it allows it to appear going off in two different directions. Because on the it can't go into a different direction. That would go against the negative parallax and shit. Like, if there can't be any negative parallax, because they all have to be going the same direction. Because the ball only spins one way. So, Occam's razor. I mean, what's Occam's razor telling us, man? And also, so to get into that, so you say, why is the sky a dome, right? Why is that? Well, celestial navigation.
A plane that includes the Earth's axis creates a great circle known as a meridian. There are an infinite number of meridians, and they all pass through the north and south.
Oh, hold on a sec.
Over the years, astronomers have selected 57 easily identifiable stars on the celestial sphere for navigational purposes. The rest can be disregarded. In addition, navigators have traditionally used the planets Venus, Mars, Jupiter, and Saturn, the Earth's moon, and the sun. To understand how these celestial bodies are used for navigation, you must first review some basic terminology. Let's begin on the Earth, or the terrestrial sphere, as it is sometimes called. The Earth rotates around an imaginary line called the axis. The intersection of the axis and the surface of the sphere are designated the north and south poles. A plane that cuts through the center of the Earth creates an arc on the Earth's surface known as a great circle. There can be any number of great circles. A plane that includes the Earth's axis creates a great circle known as a meridian. There are an infinite number of meridians, and they all pass through the north and south poles. The meridian that passes through the Royal Observatory at Greenwich, England, has been selected as the prime meridian. It is the meridian used as the origin for measurement of longitude. Longitude is the angular distance measured at the poles from the prime meridian to another meridian, east or west, from 0 degrees to 180 degrees. Every celestial body has a point on the Earth directly below it. This is called the geographic position, or GP, of the celestial body. Sometimes it is called the subpoint. If you you were at the geographic position of Polaris, the star would be directly overhead at your zenith, and you would be near the North Pole. Similarly, if you were at the equator and the sun was directly overhead at your zenith, you would be at the sun's GP. This principle applies to any celestial body, the moon, a planet, a star, or the sun. You are at that body's GP when it is directly overhead at your zenith. Now at this point, we must introduce the concept of apparent motion between the terrestrial and celestials. This is the vernal...
All right. So basically what they're saying here, I couldn't find the exact part, but you can watch it. Anyway, what they do here is they say that forget about the spinning and rotating and all and all that shit. Look at it like from anywhere from your perspective, the sky is rotating above you. So, you know, when it goes into practical use and stuff for celestial navigation, you reference the back to this preferred reference frame that they mentioned. That would complicate things, works rather well. You know, there's a massive contradiction in what they say about the elegance of the heliocentric model. And back to that presentation that Witsit Gets It gave, I'll give you the link to this PowerPoint. There's 100 quotes here of different different physicists and astronomers and theoretical physicists and stuff talking about how dark matter does, you know, how they have to invent dark matter and dark energy to justify the expansion of the universe because they can't explain why it's expanding. And then there's actually theories that to explain it, but those theories are that the universe isn't actually expanding. It just looks like it, and everything is, you know, not moving. And, you know, so they go back and forth and nobody really knows. Like, that's what that tells me. Like, the fact that these people are modern, you know, despite all the things that people think are true, and our facts and stuff, these people are like, no, it doesn't add up. So you could take a look at that. There's some interesting ones. This one in particular was really cool. This was a letter from Einstein to Ernest Mach, apologizing because he was basically, Ernest Mach said that if there was a celestial shell around the Earth and that was rotating, if that was rotating, that there would be a like a centrifugal force, you know, that would be felt on the flat plane, you know, that exists within that that spinning shell. And I guess people were using the theory of relativity to bash what Ernest Mach was saying, but in this letter, Einstein saying that, you know, hey, you were actually right, and sorry for the people that are using my theory to bash you. You're actually correct, and I really respect your work, and I sincerely apologize. It's written in German. You have to get someone to translate it. I don't speak German, but Austin Witsit Gets It from Globebusters had it translated and read it back, and that's basically what it said. So if it says something else, you know, and you speak German, like, feel free to correct it. But that's what it says, allegedly, that there would be a detectable drift based on the force of the thing rotating above us if the Earth were stationary. So they've got lots of different you know, explanations of what's going on here, and really with the theory of relativity and everything being relative motion to another object, they've kind of made it where it doesn't matter at all. You can just kind of use space-time and stuff to explain everything. So okay, I think I've done a good job explaining okay, real quick, we'll wrap up the philosophical nature of the heliocentric model. 1 second. That's where I really wanted to end on. for heliocentrism being heliocentric. So this is from Edwin Hubble, right? Can as or such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a central Earth. This hypothesis cannot be disproved. Oh, one sec. Sorry, I didn't mean to burp in the mic. Cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomena. Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all cost. Such a favored position is intolerable. Therefore, in order to restore homogeneity and to escape the horror of a unique position, uh, must be compensated by spatial curvature. There seems to be no other escape. Edwin Hubble. So this guy knows all of the things that I was talking about. Like all the stuff where they were like, oh, parallax, oh, James Bradley, stellar aberration, all these things, Einstein's relativity, everything. They're like, well, can't be disproven that we're the center because the the geocentric model works really good. It's the same. There's even quotes in here. I didn't feel like going through and finding the specific specific ones, but there's ones where they're talking about where these physicists and astronomers are talking about how elegant and simple the Ptolemaic system is. So when it's said that that the heliocentric model is simple and explains everything, I mean, I think that's objectively not true because it requires, multiple theories and explanations and things to not be explained, but just kind of generally accepted, uh, that, objectively aren't true. Like people are still saying the CMB is proof of everything. And this guy wrote about that shit in the 70s that it completely, uh, is disproven, and it's a huge problem. And nobody addressed it. Nobody gave him a Nobel Prize. You'll often hear, "Oh, in science, every day you go to work as a scientist and you try and disprove your colleagues and and stuff and put their theories to the test." That's not true at all. That guy just did it and nobody cared. Nobody cared. Um, so the philosophical nature, Occam's razor, was going to talk about length contraction. So when we talk about narratives and versus a mathematical model, well, look at when look at what you can do when I say math as a narrative, and it's a description and all these things. uh this is a good example of it right here. I don't know if you've ever heard of length contraction or the Lorentz transformation, but basically when experiments were done to prove that the earth was moving and they didn't find any movement, they basically had to come up with an explanation and say that, well, space-time physically contracted the device used to do the measurements by the exact amount, uh, to make it a null result. And so when you can do that with math, like it's 100% a narrative, like you're just constructing a story with numbers, and then that equation then allows them to change, uh you know motion and how it's detected and stuff. They they can just say anything. And then real quick, before I play this, LIGO. Nautilus, LIGO. Fuck. 1 second. We'll come back to that if I remember the LIGO thing. So anyway, here's length contraction.
Convinced the world that every time Michelson and his colleagues tried to do an experiment to prove whether the Earth was moving, nature conspired against them, as it were, and kept shortening their measuring devices and made it appear the Earth wasn't moving. Was this the answer of the fool on the hill? As noted earlier, from the remarks of some scientists, it appeared to be just that, since it was obvious to them that the easier and more logical answer was that the Earth wasn't moving, and the measuring device remained the same length it had always been. Prior to Einstein, the first ones to propose that the measuring device may have shrunk during the experiments were the famous Dutch scientist Hendrik Lorentz and the Irishman George Fitzgerald. Lorentz and Fitzgerald proposed that since Michelson's experimental apparatus was tied to the Earth, and since everyone believed the Earth was revolving around the Sun at close to 20 miles per second, the substance of space, otherwise known at that time as ether, pressed against Michelson's apparatus and thus compressed the atoms so as to shorten its length. This solution, however, suffered from a clear case of the logical fallacy of petitio principii, otherwise known as using as proof the very thing one is trying to prove. To be logically sound, not to mention scientific, one cannot use as proof that the Earth is moving 20 miles per second around the Sun in order to prove that the Earth is moving 20 miles per second around the Sun. But at this point, with the pride and prestige of modern society hanging in the balance, neither the science community nor the rest of the world was as interested in being logically consistent as they were proposing a theoretical counter-thesis to how Michelson's experiment could be forced to provide them with the moving Earth they all wanted so badly. In his patent office during 1905, Einstein became privy to Lorentz's and Fitzgerald's bold new hypothesis, and he realized with them that the only way to adjust the results of Michelson's experiments so as to provide mankind with a moving Earth was to use the same assumption that the Earth was moving, and then claim that because of that movement, a shrinkage of Michelson's measuring device had to occur. As Einstein himself puts it in his book, Relativity, the Special and the General Theory,
the Michelson-Morely experiment gave a negative result, a fact very perplexing to physicists. Lorentz and Fitzgerald rescued the theory from its difficulty by assuming that the motion of the body relative to the ether produces a contraction of the body in the direction of motion, the amount of contraction being just sufficient to compensate for the difference in time. Comparison shows that also from the standpoint of the theory of relativity, this solution of the difficulty was the right one.
But even though Einstein agreed that Lorentz and Fitzgerald had stumbled upon a plausible explanation, he didn't favor ether pressure as the cause, especially since, up to that time, ether was understood to be a discrete frictionless substance that could not put pressure on matter. But the main reason Einstein didn't want any ether was that if space was composed of a particular substance, it could then serve as an absolute reference frame, and an absolute reference frame did not bode well for his new theory that was going to consider everything relative. So, since Einstein needed a shrinkage of Michelson's device to provide mankind with a moving Earth, Einstein thought of something no one prior to him had even dreamed of. This solution, however, required another assumption, another postulate, namely, that the speed of light was constant. It could never increase or decrease. Light became Einstein's absolute, the one thing by which he would be able to measure the rest of the universe. In a word, everything was relative, except light. Since light speed was not allowed to vary, this meant that any material object an observer sees moving will appear different to him than what it really is. The reason is, since a moving object reflects light into his eye, and since that light has a limited time and speed to reach his eye, this handicap of light will result in a slightly distorted image to the eye. That is, the object will appear to shorten in its length dimension, or whatever dimension of the object that is moving in the direction of motion. This was, indeed, a very clever solution. It laid the whole problem at the feet of human perception, and not on whether the Earth was moving. For Einstein and the rest of the science community, the Earth was moving. That was a given, and it was not to be questioned. At that time, Einstein could point to many other experiments that science considered proof of a moving Earth.
Yeah, man. So once they adopted the Copernican Principle and rolled that out, it was a wrap, dude. It could never not be moving. Like they were they were they were promoting heliocentrism as fact before they even had experiments to prove it. Michelson, what was his name? Albert Michelson was a heliocentrist before he had it proven. It's philosophical in nature, and they tried to prove it and they couldn't, and they were like, oh well, mathematical narrative here, and we're good to go. So yep, so we'll move on from that. So I think that about wraps up the simple explanation of the heliocentric model and the flat Earth model, quote unquote. And nothing working on it. They're interchangeable, bro. Interchangeable. So and some people have the opinion that that the stationary one is even better, and celestial navigation works on what's called the celestial sphere, where they assume the stars are way closer. So So I hope that kind of dispels the myth that nothing on the flat Earth works. And let's see. Now we're going to move on to objects get smaller as they move away from you, correct? So we're good on that. And then at a distance, the ground and sky meet at the horizon and compress together. I don't understand what you mean here. Okay, perfect. So I'll give you an example of that. This is from a channel here. The video itself isn't important. I just kind of wanted a picture of the horizon and stuff. So as you can see, like the clouds that are closer to you, that are above you, they're high in the sky, you know, they're high above you. And then as you get closer to the distant horizon back here, you'll the clouds get closer to the ground, and the water at your feet that you're above, right? You like your eye level is above this water. It's at your feet. But as it gets further out, it appears that it's rising, you know, that it's higher than you. It's just, that's perspective. And then also, so what's happening here at the horizon is these two things are converging together, and it makes like an opaque line here where things basically, you know, you can't really resolve anything through here because it's just the limit, right? And due to weather conditions and stuff like that, atmospheric conditions, you know, the thickness of that horizon line will change. But yeah, basically, you know, like if the conditions were bad enough, this the convergence of these two lines would be harder to see, and then you wouldn't be able to see like whatever this is over here, right? For example. So that's what I mean by that. And we'll come back here. And then the compression of atmospheric conditions, clouds, blocks the sun as it moves further away from you. I'm not sure what you get. Okay, so here's a video from Dave's wife, here's a video from Dave Weiss, Ditrh, who has a great physical representation of what I'm talking about. And we'll play it at 2 times speed so we can get through it faster. 6-minute video should take 3 minutes, allegedly,
This is my flat Earth.
unless there's time dilation or something,
I have my camera filming.
or there's a Lorentz contraction.
This line here is the path of the sun, and I have this bottle here to show you that it's just over 3 fingers above it. As we go down, we have our tropical forest, we have our blue glass cutting board, and some more mountains, if you will. As the sun continues to the end, 3 fingers, we have a level line. I'm going to flip the camera around, stick it here. I'm going to dim the lights and travel to the sun. I'm going to move my bottles out of the way. Here we go, my sun, see? And here we go. We follow the sun's path, staying level over our flat stationary counterplane. We cruise over the lower mountains. Of course, this is not to scale. I can do this much higher if my kitchen was just twice as long. And we would get the same effect. I come to the end, to the firmament, and we stop. There's a camera, still at level, slightly above level, standing on the flat Earth. So here we go. I'm going along the sun's path, keeping it level to the flat Earth. Heading past the mountains. Now if this is truly the flat Earth, I have much more distance to go, and I can even have this much higher to get the same effect. So just finishing, hitting the firmament basically, and let's take a look.
So you can see there, it appears to be setting. But let's just imagine instead, well, you don't have to imagine because this is just actually what happens. But here, what he has representing it is, you know, a physical object. But this would just be that compression of your vision and the atmospheric conditions making that opaque horizon line that that as the sun moves moves further and further away, it can't penetrate through, and it appears to be setting, but it's just an optical illusion because you can actually I'll pull up the videos. Let's see. 1 second. Zooming in on a sunset. This will be. Yeah, even we'll see what Woofy even has.
So I'm back on the west coast of Australia.
Where? Yeah. So, horizon. Then this is from Woofy. This isn't even from a flat earther. This is Woofy maximum zoom does not change the time of sunset. I don't know. I don't know what he's referencing or whatever, but you know, so it's like, oh, it looks like the sun setting because we're rotating away from it, right? That's what the heliocentric model says. Look, we're rotating around. The Earth curvature is physically blocking the sun as we're rotating further away from it, and it's going down around the curvature, right? Well, the same thing's happening right here in this video. The sun's going down around the curvature, but you and I both know from earlier in the video, there's no curvature and the sun's traveling over a linear path. So when we look at the Gleason map, 1 second, let me pull up old Gleason here. Yep. So when we're saying that the sun's moving between the tropics, you know, and it spirals in and out or whatever over the seasons, that's exactly, you know, it's not going over a curve, it's just moving, and then your perspective is that's how it's vanishing from you, right? And shout out to Dave Weiss for making, you know, showing this demonstration.
Turn the light back on. I'm going to remove all the bumps on here. To show that I am above the counter, flat Earth, I'm going to slide this along a perfectly smooth flat Earth. And I'm guessing that it doesn't set. Because the Earth has bumps. To show that I am above the counter, the flat Earth, I'm going to just slide this along a perfectly smooth flat Earth. And I'm guessing that it doesn't set. Because the Earth has bumps.
Yep, look, it's going over the curvature. Right. All right, so hopefully that answers that, and then I said I can provide demonstrations of this and stuff. Do you understand those videos? Yeah, I think I do. I narrated it over pretty good. Gave some commentary on them as they were happening. I think I got a pretty good grasp of what's going on, and I demonstrated that well. And then then I asked them, or told them, I'll let you know if, or let me know if you're interested, and I'll make these links available. That was when I was gonna just like link the stuff and not present it or whatever. And then once I realized he was interested, I was like, oh, you know, I'll make the video. So this is me making the links available. And then he said, but are you interested to see where those are wrong? Yeah, absolutely. Absolutely. I don't mind hearing the counter arguments at all, because I wouldn't be able to strengthen my arguments if I didn't know, and I don't mind not knowing something and being wrong about it. So yeah, for sure. Definitely. If you've got things that you could point out about where I'm wrong about that, definitely explain. Or I mean, I'm definitely open to you explaining it. So let's see. Earth curvature, Himawari. Okay, so we're gonna move on to um, okay, so nothing on a flat Earth works, right? That was that was that was one of the claims, and I think we already touched on like the celestial side and the nature of the sky, which by all means appears to be a rotating clock, that resets, a resetting clock, um, with clear intention, with clear evidence. It's self evident that it was, designed and put there for us. And there's a philosophical um, agenda being pushed to obfuscate that and make everything material. I, that's how they've done it. They've pushed it through science and they've made everything material and they've tried to quantify it and they've given everything these weights and sizes when really it's based on uh angular size and just observations where people have made um predictive models just based on observational data. you know if you look at how eclipses are predicted, you'll find that there's a guy named Mr. Eclipse. It's Mr. Eclipse. Yeah, Ernest Espinac. Or I'm sorry, Ernest. That's not didn't say Ernest at all. Fred Espinac. So this guy just analyzes a bunch of data and makes an algorithm to predict eclipses, and that's where NASA gets their prediction or gets their, quote unquote predictions for eclipses. And that's not even people will often say eclipses and NASA and heliocentrism predicts eclipses and all these things. Eclipses and stuff are derived from their pattern, their recorded data over thousands of years. They've got thousands of years of data, right? And you can even find that on NASA's website where they cite that. So that's enough about the celestial side of it. We'll move on to the technology side of it. So satellites and GPS are often cited as proof of heliocentrism and space orbits and all these things. So we're going to look at a technology called light squared in GPS. This is what is Light Squared? Light Squared Subsidiary LLC is a company seeking FCC approval for a wholesale nationwide wireless broadband network integrated with satellite coverage. Light Squared intends to combine its existing satellite communications with ground-based 4G LTE technology that would that transmits on the same radio band as its satellites. The band is right next to the primary GPS frequency L1, and then it says why the GPS community is concerned. The GPS community is concerned because testing has shown that light square ground-based communications overpower the relatively faint GPS L1 signals from space. Although light squared would operate in its own authorized band, it is so close to GPS signals that GPS devices could pick up the stronger light squared signal and become overloaded or saturated. There is also concern that millions of existing GPS users could be forced to upgrade their devices, to accept the better GPS performance to accommodate for the new network. So they have a broad-based 4G LTE system that's indistinguishable from a quote-unquote satellite signal. So when people say, oh, and this is the LORAN system, and I'm not even claiming that the LORAN system is what is currently used, because I know that there's a signal difference, but as we've just learned, that signal difference is interchangeable from a ground-based system and a ground-based LTE system. So, a quick history on how LORAN
Operating
works.
24 hours a day, numerous nations maintain a network of LORAN transmitting stations to service the major shipping lanes. There are a pair here, for example, Sisconsit and Bodie Island. One is known as the master station, the other is the slave. For a moment, consider these two stations operating as a synchronous pair, simultaneously emitting short pulses of radio energy. Leaving both shore stations simultaneously, a pair of pulses travel out into space, in all directions, at a constant speed, roughly 186,000 miles per second, or the speed of light. Plus, the pulse from the closer station will reach the ship an instant before the pulse from the other station. The LORAN ship board gear measures this difference in time of arrival, in millionths of a second, or microseconds. It simply determines how much longer one pulse takes to reach the ship than the other pulse.
Yeah. So this was the original, quote unquote GPS. And there, we've just learned that there's a ground-based system that's indistinguishable from a GPS signal. And it would GPS devices would pick it up no problem because it's stronger than the quote unquote signal from space. So so the whole GPS, atomic clock, time dilation, Einstein falling around the space, changing how fast relative motion, none of that doesn't matter. Doesn't matter at all. It could all be done from this, and nobody would know. And that combined with balloon technology, a lot of people aren't familiar with NASA's balloon program. I didn't have anything planned to talk about for this part prepared already, but do a quick rundown balloon program. I did a video on it recently. So this is NASA's balloon program, where they put scientific equipment and radio equipment and telescopes and all these things up in the sky for up to 6 months, I believe. Now I found there was one video. I'm not going to talk about it. If I can't find it, there's no point in bringing it up. So let's go with the official narrative. What they say is they can get them up there for 3 to 6 months. Official narrative, you can find that easily documented. 3 to 6 months. These will float up in the sky, and they expand to be the size of like football fields. They're huge. NASA's able to produce, I forget the numbers, but it's like they can produce like 10,000 a day of these balloons. Like their production scale is insane on these. It's no problem for them at all. They run a bunch of experiments on them. They've really got this down to a science, and so the way that they can do communication is they'll have these balloons hover at certain altitudes, and they'll catch a jet stream current or a wind current. They'll be going at a certain area, and then they can bring in air, which will make the balloon heavier. They could lower an altitude or increase their altitude by how much air they allow in a secondary balloon that's inside of the big balloon. And they just basically catch different wind streams, and they can cover the same area like really easily. So when you're watching like a TV show and they're like, "Oh, we're rerouting the satellite," right? And it cuts to a graphic of a satellite in space, and like it might fire like a little rocket engine, or a little burst of mist will come out of it, and it'll change directions, or whatever. Um, we're like that would be kind of what that would be the micro version of what's happening. Uh, by readjusting it, they're just changing the altitude and using the natural wind flow they've already got all this stuff mapped out. So here's bobwinds.com. Really cool website. So you can go to wind and check it at different altitudes, and you can see how you can get it to go in different directions there. Where was the globe? The globe, dude. Fucking funny. Yep. So, eh. So yeah, you can just check these out if you want to look more into their balloon program. It's very extensive, and they could easily it would it, a guy named I Can Science That on YouTube helped me do the math on it, and he figured out that it would only take about 2,500 to like 3,000 balloons to really cover the entire world, the entire known world, on the Gleason's map. Like all this could be covered with like 3,000 quote unquote satelloons we call them. So just some interesting stuff. And that was based on the coverage of the NextRad system, the weather stuff, those weather domes. Like they only have about, I forget the number of how many is in the country, but it's not even that many, and it covers the entire country. So, and those aren't even that high. So if you had something higher, you could get more range. Like they could get tons of coverage for communications and surveillance and things like that that people think are due exclusively to things that are in quote unquote space. So that's for the technological side. There were satellites, light squared, the Foucault's pendulum. Let's see, where did I have that at? Foucault's pendulum. All right, well, yeah. So we'll watch a quick video on the Foucault's pendulum. People will cite this as proof that the Earth moves. It's not a Foucault's pendulum will lose its momentum and stop working. It'll often end up reversing its momentum and going in a different direction. It does all kinds of weird shit when it's not powered by an electric motor. So here we go. Let's just watch this. Just watch this. Satanic ball worshippers like to keep pushing their Masonic Foucault's pendulums. Nothing but a big hoax.
And so just below the dome there, you have probably one of the more famous Foucault pendulums here in the United States. Now, listen to what the tour guide had to say.
This video is from Rob Skiba. This is a clip from Rob Skiba. Peace be upon him. Died last year or earlier this year, I forget. But peace be upon him, man. He did tremendous work.
say about how this thing works.
If you're wondering how we keep it going with an electromagnet. Otherwise, due to air friction, it would slow down. We'd have to jump in there every hour or so and give it a push. But our electromagnet keeps it going even after we close at night. It keeps going and swinging back and forth even after we close.
But our electromagnet keeps it going even after we close it. It keeps going and going, swinging back and forth even after we close.
You put a little motor in the top and give it a little jiggle and put energy in at the top, which is somehow cheating because you're actually pushing the damn thing, and you have to make sure you push it in a way which is not going to cause a torque. So that's the way it's done in a lot of museums.
Not everyone realizes that they actually have a magnetic drive plugged into electricity that keeps them moving. Now, the only reason I know this is because I worked for a construction company that installed one.
Alrighty, and then he goes on to show some Masonic connections between your boy Foucault and the Freemasons, but you're probably not interested in that, and I don't think it'll help to show you the rest of that. But that's what it is. If you're interested in seeing that connection, you can check out the video. But yeah, you'll often find that a lot of these guys are in some sort of secret society, and they have all got some particular worldview. And anyway, let's see. So Foucault's pendulum, cosmological predictions. So we did eclipses already. The interchangeable models. The Einstein quotes. Okay. So let me just make sure that's everything. Satellites. Oh, okay. So for satellite technology, real quick, we'll just breeze through this. This is, people will often say the Himawari and pictures of Earth from satellites are proof. Well, I have a video on my channel actually called playlist Space Audits. It's Space Audit Discover, where we go over raw data of the Discover, which is claiming to be, presenting real pictures of Earth and stuff in real time and all that kind of shit. So me and that guy, Icon Science Dad, he's a professor at a university as well. We collaborated, and he actually found the raw data of the Discover satellite, and he compiled it, and we went over the images and stuff. And there's no, and he agreed to that. There's no way to discernibly tell if those are authentic pictures of Earth or if those are computer generated. But he leans towards that they are authentic. They have no metadata on them, by the way. Like a lot of people, you'll see flat earthers cite, they'll go to NASA's website or some media publication and pull the pictures off and run it through the metadata thing. Those pictures are always going to come back that they were photoshopped. One, because they're packaged for the media to make it look good. Like they're always going to touch them up and do things to them. So it's always going to return that on stuff that's public. Now what we should do is analyze those raw data pictures that I found, because that would be more telling on what's happening with the pixels and things like that, because there's no metadata on those. There's nothing to reveal on those. I've looked into it. But anyway, this will be a quick demonstration on how they actually fake cloud formations and stuff and model and model them out over the oceans in these pictures, and like they're not real. It's just computer generated. They have an algorithm for it. They've already made simulations of weather patterns for like the next 90 years. So we'll watch this real quick.
Show you how they generate a picture every 10 minutes with what appears to be accurate and current weather. This is basically what they do. Now, don't take my word for it, as I always say. Go check it out for yourself. Number one, they have already created and stored transparent images of the weather over the oceans using climate simulation software, which they openly admit right here that they've done climate simulations up to the year 2095. But it's actually the year 2100 on this FTP server folder, and here's one of the images. And following some of the other images that you can find where the land masses are transparent, and they use all this simulation software.
And you could go to that FTP server and download those for yourself. I've done that.
Use ground-based systems to cover the entire vast oceans. So that's where the weather over the oceans comes from. Their software simulations. Number two, now for the weather over the land, the NOAA has supercomputers that take data coming in from all over the world, Doppler radar feeds, and crunch it all together and combine it with the weather simulation data.
And those Doppler radar feeds and all that stuff, that was part of that NextRad system. Let me show you that real quick. This is where 100% of the data. NextRad. This is where 100% of the weather data comes from. It comes from these towers with these spheres on them, these radar systems. These are how many are placed in America, and this provides, so whenever like the weather is the Weather Channel, or oh fuck, what did I just close? Shit, whatever is referencing whenever you're seeing weather stuff on the news and whatnot, and that's what it's coming from. It's coming from this network system of ground-based radar, right? Very important to note, not from satellites. There's also weather balloons, obviously, right? But there's not, there's, all of it comes from not fucking satellites in space. So.
The ocean, so they come up with a complete composite weather quote-unquote map, which is...
Yeah, so this map is derived from this radar system. So just making that clear.
And wrapped around a ball in their 3D modeling software programs, just like we've shown countless times in our previous episodes with the Earth and the planets, etc. So then what we get are composite images like this that are created in the 3D modeling software, the current Doppler weather data over land, and the simulated weather over the oceans, and it looks like this. So this particular image is on the FTP server and is date and time-stamped with October 11th, 2017 at 11:05 a.m. I just chose one randomly. Notice the image shows you the weather for the whole ball, and not just part of the ball that is lit by the sun at this particular time. No Terminator line or anything like that, right? Okay, now here's the kicker. Go to the other file folder, which is the images that we get to see and are told are real pictures from space. But what they've simply done is taken the weather map picture of the whole ball they created, and they superimpose it over the blue marble data set, just like they said they did. So what you can see here is the final version of what we're spoon-fed and told is a picture taken by the Heliocentrism from space, like 10 minutes ago. This is the image from the same date and time, October 11th, 2017 at 11:05 a.m. And you can see that the weather is exactly the same. Watch it closely. There's your weather map comprised of simulated and Doppler radar being used to complete a composite image. They do this with the Discover satellite too, the epic camera from a million miles away, they tell us. Ridiculous. Okay. Now also notice the final image has a Terminator line added in to try to make it look like a real picture from space, which drives a nail in the coffin of the Heliocentrism because the weather data shows it over the whole ball completely. But they had to add a Terminator line to show the Earth only partially lit by the sun based on the time of day that the photo was allegedly taken. So if this is a real picture, how did they know where to put the clouds and weather on the part of the globe with no sunlight? It's completely dark there. It's all right here, guys. They are faking space. Hey, we all fell for it for a long time with their Doppler radar and weather simulation software, building a current weather picture and wrapping it around a ball in 3D software and pasting it onto a black background like they do with all the others, adding a Terminator line and calling it a real picture from space. Heliocentrism debunked once and for all. This has been Paul on the Plane. Thanks for watching.
All right, that was from Paul on the Plane. That was from a montage, or like a montage documentary from a guy named John Thor. Cool channel, check him out. This he goes over the balloon program too and has some interesting stuff in there, and they explain that technology I was talking about where they let air into the balloon to increase its altitude and whatnot, and how they control it. So very cool. So check him out. And let's see, Loran GPS quotes. There's tons of quotes that you can check for in favor of geocentrism. I couldn't verify all of these, and I got kind of bored doing it and going through them all. But apparently these people said these things, so that's something to consider possibly. And we'll watch this quick presentation on, actually, before we finish our perspective, we'll let me talk about all these government documents that reference a flat Earth. So you know how we were talking about the preferred reference frame that the Earth is not moving, you know, and that you technically could define it as that, but it would be a problem, you know, but like Occam's razor and all that. Well, in all these documents from the government, from NASA, the military, etc., flight manuals, radar systems, weapon systems, you know, all these things all reference a flat, non-rotating, stationary Earth, right? So that they can model out how they do their shit. And I can make this document available to you, and you can check these links out. But yeah, the whole yeah. So yeah. And I haven't even read all of these. I'm just kind of scrolling through myself because I'm just kind of interested in them now. 3D data modeling spatial. Okay. So anyway, you can check that out. Check these links out, and see what you think about how they model out and always refer back to a stationary, non-rotating plane, or they'll refer to like an aircraft moving over a non-rotating stationary plane. You know, they always reference it as that. So, but when we say it, you know, it's like we're crazy, you know, but it's all good. What was the last thing? Oh, yeah, perspective. So this is a quick demonstration on perspective. So if you can point out, you know, you said if I was prepared to hear why something is wrong or whatever, I would definitely like to hear your thoughts on this, and especially where it gets to this part. I'll try and breeze through this. I don't want to take too much more of your time. But okay, we'll just play this, and you can give me your thoughts on this.
Call it the personal atmospheric dome or the pad. And here's the thing I think people miss is that this is not a theory. It's not an idea. It's the truth. It's a fact. And you can figure that out on your own by just simply knowing that if you look up, that's the least amount of atmosphere that there is. It's right above you, straight above your head. So if any light is coming directly down from straight above you, that has the least amount of refraction. It has the least amount of effects. Those rays are going to come at you parallel if the sun's right above you. And then if you look to your left or right, or straight ahead of you or behind you, that is the most amount of atmosphere. So right away you can tell if the least amount of atmosphere is above you and the most is to your sides. That creates a personal atmospheric dome. We all see through it. No matter where you're at on the Earth, no matter North Pole, South Pole, wherever you might be, you exist inside of a personal atmospheric dome where everything renders to you. So nothing can just appear in the sky. It all has to come from far away. So that's why we see things come up from the horizon line, right? And so this is a dome. We see as a dome, and if you think of the sky being a plane above you, so a plane of stars above you, as things get further, since you're looking through more and more atmospheric distortion to see them, things appear to bend down towards the horizon line. And so that's the personal atmospheric dome. And when you understand that, then you realize that no matter where you're at on Earth, you see the sun rise to the east of your personal atmospheric dome and set in the west. And so people get very tripped up and they say, well, what about in the south? Isn't it the opposite? Where it's just, no, they are looking north. And so things rise on their right and set on their left, whereas us in the north, we look south and things rise on our left and set on our right. So it is a personal atmospheric dome. And then you have to learn to understand that. So many people get caught up in the idea of, here's the fooling part. You live in a personal atmospheric dome. That's what you live in. That's what you see things through. They convince the world that there is another personal atmospheric dome below you with somebody living upside down inside it. And that's the biggest fooling point of the entire thing, is that no, you exist in your personal atmospheric dome. That's how you see things. When you watch a plane fly off into the distance, it doesn't just fly straight up and then disappear into the clouds. It goes down towards the horizon. That's the way everything works. Just like the sun sets, just like the moon sets, just like the sun rises, just like the moon rises, just like a plane coming over the horizon, as you might term that, but just means it's coming from far away. I can't see planes from where I live leaving the San Francisco airport. It's too far. But as things get closer to me, I would see them appear not out of the middle of the sky, but from the horizon line, because it's finally rendering itself to me. It's big enough to come into my personal atmospheric dome. And that's the way the entire world works around you. It's hard to explain, I guess, the personal atmospheric dome for people to get, but one visual that I thought was really good is if you picture a really foggy day, so it's extremely foggy, and you're at a train station and you're reading the train schedule, and you would only be able to see, let's say, you can only see your own train schedule. You're looking at it, and if you look any further, it's too foggy to see. So, but if you think about there being 10 other people at this train station at the same time, and everybody's looking at their own little document, well, they can read their own little train schedule, but to all of them, they can't see the other people around them. That's how the Earth works. That's how our atmosphere works. Same thing when two people on flat Earth are standing near each other, maybe 4 or 5 miles away, but to each other, the horizon ends before you can see the other person.
I don't know if you guys have seen this. Shout out to Flat Earth Awakening, and believe it or not, to Walter Bislin. I'm sure you guys know who he is. If you don't, well, you'll probably catch him in your comments section at some point. But I want to play this video. 3 minutes and 45 seconds. Actually, it's mostly music, so I'm just going to mute it. There's only one part that has any audio. But what this is taken from Walter Bislin's Flat Earth Modeling app, and what it does is it shows the personal atmospheric dome and how it works. Now, I have to remind you guys that Walter Bislin is a ball earther, right? He is absolutely not a flat earther. He thinks it's silly. He's battled, in several comment sections. He battles Flat Earth FE Core. He's just really a baller. And what's amazing is he has come out with this app, and it shows precisely what we have been talking about this personal atmospheric dome, right? And this is very similar to P-Brain's graphics, but it shows the sun and the moon rotating above a flat Earth, and with our personal atmospheric dome, how it actually is perceived by us. And it's really quite an amazing app, and you can actually go there and play with it on his webpage. But I just want to let this run a little bit so you can see actually what's happening here. You can see the continents and how, or I'm sorry, you can see the stars and how that you're perceiving them. If you move latitude, anywhere in the latitude, you can see, of course, that personal atmospheric dome then starts turning on its side until you get to the equator. Then it's pretty much equal, and that is, of course, when we've seen all of that star trail footage that splits off in two different directions at the equator. And then if you continue further south, the personal atmospheric dome kind of starts tilting back up at an angle. So the one thing about this also that I want to point out is not only does this back up 100% what Jaron has talked about and a lot of flat earthers, but it also backs up 100% exactly the idea of how an EQ mount on a telescope can work. Just like we said before, when you are dealing with optics and we have a personal atmospheric dome, and it doesn't matter if we're looking at it with our eyes or a camera is looking at it, if you set up a telescope and calibrate it to either the south pole, south celestial point, which is not a star, or north pole or Polaris, calibrate it, and then you follow any of these grid lines around, it follows and tracks absolutely perfectly on a flat Earth. And in fact, beyond that, if you really start thinking this through, and this is the one thing that the ballers never, ever, ever want to take into consideration in their models, is how you see how our perspective actually works. They're always trying to use these orthographic type views, side-on views, and do all their math and geometry from that. Well, great, and it works that way, but unfortunately, we don't see the world that way, right? And neither do telescopes, ladies and gentlemen, okay? So what this not only proves is that the telescopes, the EQ mount telescopes can work and do work on a flat Earth, but if you think about it, if that same personal atmospheric dome is then applied to a ball Earth, then the EQ telescope will not work at all, okay? Think about that for a while, guys, because you've got basically a double whammy there. You're going down the latitude of the globe, which is what they say the scope is tracking. However, at that point, they are assuming absolutely no personal atmospheric dome, and if you were to factor that in, it wouldn't work at all, plain and simple. So, at this point, I think I'm almost obligated to ask the ballers to prove to us, using atmospheric and our perspective in a personal atmospheric dome, how an EQ mount telescope could possibly work on a globe.
Hello, everybody. Steve Matthews here, and today we're going to talk about...
All right. So that's the personal atmospheric dome and perspective and how sunsets work, or sunsets and shit work. I think that's pretty much everything that I wanted to cover. If you have any further questions for me, definitely hit me up. And, if you have any critiques or insights that you want to share or mention, let me know. Or make a video too, man. Like, get involved, bro. Or we could do a live stream or something together. And talk about it in real time. Sorry this went on a little long, but I kind of wanted to present it as like a conversation and just kind of like go over it together, and walk you through the process, because you're right that it is a narrative, but I hope that I was able to showcase to you that heliocentrism is also a narrative, and mathematics used to describe it is a narrative. And it's gotten to the point where they took an experiment and philosophically allowed themselves to ignore the results by following a mathematical narrative. So when the math checks out on a lot of stuff, like I'm not super concerned with it, you know what I mean? Because they've had a lot of time to work on this model, and these people that have worked on it are really fucking smart. And you can see, I hope you can see the bias from these quotes that we're up against. Like Newton didn't even want gravity to be attributed to him because he thought that action at a distance was dumb. But we're all taught that Newton, gravity, blah blah blah. So so people have started waking up and questioning that, or not waking up, or waking up, but have started realizing that, and then they started questioning the heliocentric model, and they've come to these conclusions that even these people don't know and are still trying to figure it out, and that it's indeed philosophical, and for me, where I stand on it is that it's philosophical because here's why it's philosophical, or never mind. That's where, with the way I look at it, for me, is like water is level, right? Like that's that's a given. You know, water seeks a level, it takes the shape of its container. You know, we'd have to be on a level plane, you know, to have sea level and shit. You can't have sea curvature. Like, there's no sea curvature, right? You know, so they have weapon systems that go, you know, miles and miles out to sea and detect things miles and miles away when there should be curvature blocking it, you know, and there's just not. I just don't think there's any meaningful way to demonstrate curvature in large bodies of water. You know, and it's gotten to the point where I've talked to, you know, high level educated people about this uh lack of curvature, water curvature, and they've said to me, well, water seeks a curve. And it's like, you know, if I was like, yo, $1,000 bet right now, fill in the blank, water seeks a, or water's, you know, you would be like, it seeks level, you know, it seeks to be level. That's how you would answer. You would never be like, oh yeah, it seeks a curve, you know. So you can find giant lakes that are, you know, that like have mirror reflections. You know, because they're motionless and fucking perfectly still and they're flat. You know, if they were curved, the reflections would be curved, but they're like, you know, perfect mirror images, like mirror image. Yeah. There's some really good ones that people put on like flat earth channels and stuff, but just a quick Google one. Yeah, like these are, there's no water curve, man. So that tells me that we're in some sort of contained system, right? And then if we go to bobwins.com, like look at the jet streams and air currents on a flat disk, on this flat spherical disk. And here's one that I like, the magnetic one, because you can see here how the magnetic declinate or Earth's what is it called? Torus field. Yeah, so you can see how this works on a flat Earth with a central magnetic source. And you see how it's like rotating and changing. So when you go to Google Earth, hold on, actually I have Google Earth Pro downloaded. I need to Google Earth. Might as well use it, right? If you don't use it, you lose it, or whatever someone said once. All right, so where was I? Google Earth. Oh, right. So the magnetic stuff. If you go down here, you'll start to see that the magnetic declination stuff is like 180 degrees, almost like a complete turnaround and stuff. So when you try and figure out, like when you apply like why there's such this big discrepancy in magnetic declination in Antarctica, you know, okay, so let's look, instead of looking at it from a globe with a toroidal field like that, look at it like a flat disk inside of a toroidal field. You know, the plane of inertia or whatever inside of a toroidal field. And then these edges would be where it's looping around. So a spinning toroidal field is Antarctica. That's why when you come down here and it says, oh, you got to turn 120 degrees, 130 degrees, 160 degrees. It's because you're turning around this turning around this. And that's why a lot of what's you know, I don't want to speak for like a lot of flat earthers or most flat earthers or kind of thing, but things that are commonly promoted in the community that I see are like these maps of different of like an infinite plane kind of thing. I don't think that it's an infinite plane because this is the edge right here. So I think we're definitely within this kind of a situation. This just might be significantly larger than what we're led to believe, and they can, you know, slice that out and change things with this magnetic declination thing and GPS and stuff. So you would have to like physically go on an expedition and stuff. But from my understanding with the Antarctic Treaty, which is the 60th South Parallel, you're not allowed to travel unless you have special permission from government agencies and different countries and all these things. And you can look into the Antarctic Treaty. There's a really good video by Taboo Conspiracy who breaks down the Antarctic Treaty. But yeah, so trying to travel to something like this to see if there's like more land or something here, we're not really allowed to come out here. And it's patrolled by, you know, the U.S. military. You know, they got nuclear submarines that just run routes and shit all through here all the time. They've got icebreaker ships that come through here. Like they run all through here, you know, or you know, from their perspective, it would be all through here. But what we're saying is that it's different than you know, slightly different. Same but different, you know. So yeah, I don't think there's an infinite plane or that there's other realms outside of here, or maybe there could be. But this particular pocket is closed here. Like, I don't think we can leave here and there's another thing that we can access out here. Some people do. But I think that this magnetic field is evidence that that's not true. Yeah. So you can see the where the bend back is going. But see, there's also something weird going on over here. Or well, I don't know. I guess that's how it wraps. I don't know. All right. Thanks for your time, and I hope you enjoyed. And I look forward to hearing your thoughts on this.